Okay, welcome back, part two. So let's take a look at the second graph. They want us to write down where sine 2x, which is one of these graphs, equals the other one. So again, that's looking at where they cross, their intersections. Okay, and it appears that we have those four intersections. So just kind of estimating those from the graph. The first one, so this is 2 pi. Halfway, 1, 2, 3, 4, 5, 6, this would be pi. Halfway to that would be pi over 2. And so this is kind of a third of the way, so that would be pi over 6, right? So in other words, 1, 2, 3, 4, 5, 6 tick marks to get to pi, so this is 1/6. All right, this one is pi over 2. And then we also have, this would be, looks like 5 pi over 6. And this one looks like pi, which is 6 over 6, 7, 8, 9 over 6, otherwise known as 3 pi over 2. All right, now if you compare that to what we got up above when we solved it algebraically, we only got these two, right? So what happened to these other two? Well, it could be that by dividing by cos here, we actually got rid of some of our answers, which we shouldn't have done. So this was wrong, wrong, wrong. Do not do that. Okay, so essentially, good way to go about this is if you have time, check your answer graphically just to make sure that you have the right number of solutions, okay, that you've got everything covered. Okay, so they talk about what circumstances that in general you wouldn't divide by cos x on the next page, but I mean what it comes down to is you really just want to graph it to check it, and typically you don't divide by something that cancels off completely. Here cos didn't really cancel off, it just turned into tan x, sine x over cos x. Okay, here we got rid of some of our solutions, which we shouldn't have. Okay, let's look at the next page. So in part E here, what we're going to do is we're going to actually solve it how it should have been solved, which is, so we replace sine 2x with 2 sine x cos x. Okay, and then what we should have done was actually subtract cos x to the other side so that we have 0 on one side. That's usually a good bet of what we want to do so that then we can factor it. Okay, and what can we factor here? Let's think greatest common factor. Well, we could take out cos x. So factor cos x out. From this term, we're left with 2 sine x minus, and from this term, we're left with 1. So there's our two factors. Now we can branch each one off to equal 0. Cos x equals 0. 2 sine x minus 1 equals 0. Isolate sine x. And there we go. So each of those, we're kind of off to the unit circle. Where is cos 0? Up here and down there. And look at that. There's your pi over 2, 3 pi over 2 that we missed by canceling off cos theta or cos x. And this one is still what we had from before for where sine is 1/2. X would equal pi over 6 and 5 pi over 6. So you'll see we got rid of that cos, and by doing that we got rid of 2 of our answers. So these would be all 4 of our answers. All right, so let's take a look at example 3. Okay, solving equations using double angle identities. So a couple ways, a couple important things that they talk about on this one. So diagram shows the graph of two functions. Y equals g of x is the bold line. Y equals f of x is the thin line. And we have these graphed for 0 to 2 pi. You'll notice 2 pi on the x-axis. Write an equation which has a solution provided by the x-intercepts of the graph. So one equation that shows these as being our solutions. Well, essentially what we're doing by marking the x-intercepts is we're saying this is where y is equal to 0, okay? Or this is where y equals 0 for this one. So in other words, each of these functions, f of x was set to 0 or g of x was set to 0. Or combining that back into one equation, what we would do is we would write that as factors and equal to 0. And that way each of those factors could equal 0, and that would give us all our x-intercepts. Okay, this finds our x-intercepts. Now, next thing they want, write an equation which has a solution provided by the x-coordinates of the intersection points. Okay, so the intersection points would be these points. There, and here. Now, where two graphs cross, that means we want to actually have them equal to each other. So it would be f of x equals g of x. And that's basically if we had an equation like that, and that's what we've been using a lot. So put the left-hand side into y1, the right-hand side in y2, find out where they cross, right, to solve that equation. So that's really the idea with that one. So here we're finding intersection points to solve the equation. Okay, most often we're doing part B, but that doesn't mean part A doesn't work. Okay, so let's look at the next page. Okay, so they're giving us the equations for those graphs now, g of x and f of x, and they want us to actually find the roots using our graphing calculator. Okay, so why don't you guys do that? Now it says to determine the exact roots of this equation. So how did they kind of combine f of x and g of x here, do you think? It looks like maybe that cos 2x was brought over to the other side. So it looks like possibly that started off as 3 sine squared x minus 2 equals negative cos 2x, and then they added the cos 2x to the other side. So really what are we doing there when we're trying to solve that? We're trying to find where the intersection points are of those two graphs. Okay, so let's grab the graphing calculator, set your domain to that, make sure you're in radian mode, and you're going to put this in the calculator. Please make sure, so y1 equals 3, and then you'll need a bracket because we have to square the sine x. Automatically puts a bracket in on the x, squared plus cos bracket 2x bracket minus 2 equals, oh, and then in y2, we're putting 0. Okay, all right, and this will be your x min 0, x max 2 pi, and there we go. Let's go ahead and solve this. Pause your video, go to your calculator. Okay, so we should have found one of these intersection points of 1.57. Now, to get the exact value of that, if you recall from a previous lesson, your calculator just stored that in x. If we divide the pi out of it, so divide pi, we would get, well, a fraction. It's close to 0.5. So that means that solution is going to be 1/2 of pi, right? Because we put pi back in. So one of our solutions is going to be pi over 2, 1/2 of pi. And the other one, if we go back, take a look at your graph. If that's pi over 2, what do you figure this one's going to be? 3 pi over 2. Yeah. Okay. Now, second part, use a graphing calculator to determine the roots of the equation. So take a look at what they did this time. Here's our g of x, negative cos 2x. Okay, notice it didn't change sign. Plus, you'll notice, poor choice of words, not plus, you'll also notice that the second function, f of x, is a factor, right? So that's sort of where we're finding our x-intercepts, okay? Where you would set each of those factors equal to 0 to actually solve that. So you're just going to put this in the calculator and we'll find our x-intercepts. So here we are trying to find the intersection of the two intersection points, okay, x-coordinates of them. And here we want to find our x-intercepts. So go ahead and do that. See what we get. See if we get the same thing. Okay, so we should get a graph something like this. And again, as I said, we want to find our x-intercepts, basically where this is equal to 0. So that would be these 4 points. To find, best probably way is find that is put 0 in y2, and then you can use your second calc, intersect, enter for first curve, second curve, and then go closer to, if you want to hear me tap it on my screen here, go closer to that first one to get it. Hit enter. Okay, let's see what that is in terms of pi. So it just stored it in x. We're going to divide pi out of it. And then we're going to math fraction, but you probably recognize that as 1 over 4. So our first solution here would be pi over 4. And if these tick marks are at every pi over 4, then this would probably be 2 pi over 4, 3 pi over 4. So we've got x equals pi over 4, 3 pi over 4. Okay, let's look at that graph again. 3 pi, 4 pi over 4, 5 pi over 4, and 7 pi over 4. There we go. And if you want to confirm that, you can find those ones more exact rather than guessing like I just did. Okay, now algebraically. Okay, this is where it gets a little more interesting. They want us to find the roots in C algebraically. Okay, now C had two parts to it. We had this equation, 3 sine squared plus cos 2x minus 2 equals 0. Okay, so we're going to do that here. This is your I part. 3 sine squared x plus cos 2x minus 2 equals 0 for the domain of 0 to 2 pi. Okay, and then the other one, double I, is going to be for negative cos 2x brackets 3 sine squared x minus 2 equals 0. And again, same domain, 0 to 2 pi. All right, so let's take a look here. Let's start with that first one. All right, so remember the process. First thing you do is look at the angles to see if they're the same. We have x and we have 2x, so they're not. Right away, okay, and unlike this one, notice they're not the same here either, but this one's a little different because it's already nicely factored. So let's just go over here for a minute because this one's easier. Because it's nicely factored and equal to 0, this actually is a little easier to solve because it is ready to go to set each factor to 0. Didn't need the same angle, didn't need to really do anything there to simplify that. So here, I'm going to solve this one first since we're here. Divide by negative 1, we'd still have 0. Here we're going to isolate sine squared by adding 2 to the other side and dividing by 3. And then we have to square root plus or minus the root of 2 over 3. Oh, that one's going to be fun. Calculator time. Okay, this one, let's see. Let's replace cos 2x with, say, the 2 cos squared x minus 1 identity, okay, from your formula sheet. We want to change that back to a single angle so that we can solve this. And then we isolate cos squared to get 1/2, square root both sides, and we'd have cos x equals plus or minus the root of 1/2, which is actually one we know. That would turn into the root of 1 over the root of 2. And then if we rationalize that, we get root 2 over 2, plus or minus. Okay, now let's go back to this. Oh, so we could finish this one up actually. Okay, that's a unit circle one. Root 2 over 2, where x is plus or minus, so all 4 quadrants, and root 2 over 2 is where it's 2 of a kind, so we're at the quarter pies. So our answer for that one would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, good. Back to this one. Sine x. Now let's compare that to what we had up here. Oh, those are the only answers we had. Okay. Let's see what happens with this other branch of the equation to see where this one's going to go. Okay, so the square root of plus or minus root of 2/3. Okay, so we're going to need the calculator for this, and we're going to get our reference angle first. So our reference angle is going to be the inverse sine of the positive root of 2/3. Okay, so go ahead to your calculator, get that in radians, what that reference angle is. All right, and I will do that as well, so pause your video. Okay, so if we did the inverse sine of the root of 2/3, we get a reference angle rounded to the nearest tenth of 1.0. So here's where I started questioning what I was doing on this one, because remember this one up here is this particular graphical solution, and we only got the 4 answers from our graph when we graphed this in y1 and that in y2, and you'll notice in the question it said round the answers to nearest tenth otherwise. So I was starting to wonder, why is that happening? So, and yet here we're getting the 8 answers. So here's what I did. I went back to the graph and I put this in y1, this in y2, and then each of them equal to 0. So all the x-intercepts would give us all the solutions. And so as a result, we would have a graph that looks kind of like that. So if you go at it that way, we're going to get the same answers and it should work out. Okay, so we're going to finish this up in part 3. Should be a short one. See you then.